Hello students, welcome to my channel. In this video, I will discuss a question from the current electricity and it is based on the instruments like galvanometer. So we talk about the sensitivity of a galvanometer in this question. Let us see the question. The number of turns of a coil of a moving coil galvanometer is increased in order to increase the current sensitivity by 50%. So the number of turns are increased so that there is an increment in the current sensitivity by 50%. Then the percentage change in voltage sensitivity of the galvanometer will be. So first of all, you need to know what is the meaning of current sensitivity here. So current sensitivity. The current sensitivity. So let us write here it is current sensitivity as deflections per unit current. Deflection in the galvanometer per unit current. That I can write as number of turns in the galvanometer, magnetic field that is applied, area of the coils divided by torsional constant K. So you know that there is something like north pole will be here and there is a south pole will be here and there is a coil with some number of turns n. This coil is suspended with the help of some bronze wire, so which is having the torsional constant K, and area of the magnetic area is known for us. If this is the rectangular shape, length into breadth, whatever it may be. B is the magnetic field which is produced here. B is the magnetic field which is produced here. Something like this structure you know already. So what happens here? In the magnetic field there is a torque. That magnetic torque will be is equal to mu cross B. Mu is the cross B, magnetic dipole moment, that can be written as current multiplied by area. So if there are n turns, I will write for n turns into B. This is balanced by torsional torque which is developed in the suspension wire, generally made with the bronze, that is written as K multiplied by theta. So at equilibrium, I will write these two torques will be equal, that is equal to torsional constant multiplied by theta. So this is the basic idea you know already. This is the formula for current sensitivity. What is the voltage sensitivity? The voltage sensitivity is there also deflection per unit voltage, that is potential difference. So by using the relation V is equal to IR, that is V is equal to current multiplied by resistance. So dV can be written as di. So from there it will become 1 by R into d theta by di. That is current sensitivity divided by resistance of the coil which is used here. Okay. So these are the basic formulas you need to remember here. Now see the question. The number of turns of the coil increased in order to increase the sensitivity by 50%. So number of coils, so that means the turns will be affecting here. So that means the current sensitivity is directly proportional to the number of similar coils. So what they have said here, current sensitivity is increased 50%, that means number of turns are also increased 50%. So number of turns also increased 50%. Number of turns increased 50%. So when the number of turns increased by 50%, what will happen? Resistance also increases by 50%. Resistance is directly proportional to the length. When the number of turns is increased, indirectly length is increased. So that means resistance also increases by 50%. We all know that resistance is equal to rho L by area. So cross sectional area is not changed here. The loop size is also not changed here. Only length. So number of turns becomes like if one loop is there, if it is a square, the total length is 4L. If two loops is there, 8L. If three loops is there, 12L, like that. So as I can write here, voltage sensitivity is directly proportional to current sensitivity even divided by resistance. Resistance means number of turns. So what you can say here, current sensitivity is increased 50%, even resistance is also increased 50%. That implies here no change. So no change for voltage sensitivity. So the answer comes out to be 0%. There is no change in the voltage sensitivity. So that means if a galvanometer is good for current sensitivity, that may not good for the voltage sensitivity. I hope it is clear. Thank you. Thank you for watching my lecture. Please subscribe my channel. Don't forget like and share of this video. Thank you.